Hello, this is David Hilster. I am a critical thinker, dissident scientist, and I'm here to tell you the truth about science. Something your university professors won't tell you, the mass media won't tell you, and certainly those science evangelists won't tell you. Once in a while I get a question that's a rhetorical question, sometimes it's a nasty question, sometimes it's an honest question, but I do get questions that are interesting, and I thought about this for a long time, and I actually think it is a great question, especially for people who are not used to even the idea that there are people working outside the mainstream, let alone making new models of the universe. Come on, where is this coming from? And the question is pretty simple. Do you have any proof for these new models? Now, of course, we all know that there is no proof for anything. I'm not going to talk about that. That's sort of avoiding the question in some sense. But it is true. We can never prove any model. All we can do is support models. We can say, here's a model, and it agrees with this and this and this, and then something else comes along it doesn't agree with, and we either throw the model away, we modify the model, or we come up with a new model, whatever it is. And yes, so you can never prove a model. Ever. So we can get that straight. But the truth is why and how do we judge the models we have? Why do you do this? Why do people make these models? Why should we even pay attention to them? And that's a really good question. I even made notes today so you can see that I really am a little bit more organized than normal. The first misconception that we have is that people who are outside the mainstream ignore scientific method. They basically throw away everything, throw away all the data. They don't care. Look, I'm coming up with my model. I don't care what the data says. Everything's made out of this. Toroids. Wow, it's so cool. No, that's not the way it happens. It's not that way. Once in a while, you do get people who do that. But in general, the really good models outside the mainstream, the ether models, the particle models, the action at a distance models, and the lattice type models, they are not simply, oh, I'm just going to make a model, forget about everything. It doesn't work that way. So this idea that people who make new models do so by just ignoring all the science that has come before them or all of the scientific method, and we're just going to do that. And hey, just my model's better, like it, this is the way the universe works. No, that's not the way it happens. So you can throw that misconception out. That's exactly almost the opposite of the way this whole thing happens. And that comes from one very important observation in general, and that is, what is wrong with current models? What is wrong? That's where most of all of the good models start. They look at the models today, and obviously there are things that people feel that are very wrong about the current models. Let's take the particle model. It's a zoo of particles. It's got all these attributes that have no physical sense. It's just like Dr. Alexander Unzerker says, they're just arbitrary packages with arbitrary attributes. And that is extremely unsatisfying. I don't think the universe, in my opinion, is made of arbitrary this or that, or it's just there. But the way we break it down and the model that we have, the particle model with 19 free variables, I mean, it's a mess. So that's one of the ways we look at it. The Big Bang. Well, why do we think there's a Big Bang? Well, everything's expanding. Well, why do we think everything's expanding? Well, light redshifts. Well, why is light shifting? Well, maybe we don't know how light works. Maybe this idea that light goes, like Dr. Glenn Borkert, who I interviewed just a few days ago, said, hey, when things are traveling, we believe things are things, including light is a thing. It is traveling, it's going to suffer from the law of things are going to get in its way and it's going to slow down. It cannot go infinitely long at the same speed without having some effect. So yes, that is an observation. Those observations come from, oh, look at the problem of the Big Bang. Then we have the problem with plate tectonics, for instance. Plate tectonics is something when we look at the way things are working, how do we explain all these bizarre things like all the land masses on one side? And do we ignore all the data that we see that gives us other ideas of what's going on? And that's gets me to another point, which is, what does the data tell us? What does the data tell us around the world? When we see these things that are wrong, there's a couple of things that we do see that are very wrong. Number one is physicality. There's no physicality for almost anything we talk about. Space-time, I mean, space is nothing, time is movement, or the measure of movement. It's nothing. How many times do we have to talk about this? Yes, there's no physicality for what we know as light, what we know as gravity. Oh, light is a photon. Well, it's a wave. How can it be both? We have the physicality of what is a magnetic field. What is gravity itself? It's the bending of space-time. If you bend something, it's got to be physical, yet we have no physical. Oh, well, it's the blanket. I call it the blanket, but they call it the fabric. I call it the blanket because it sounds more like immature, like blanket for a little kid sucking their thumb and eating their blanket. Yeah, that's what they need. They have to literally put some word in there to put a physicality into it. That's one of the problems, of course. And the other problem is bad assumptions. They make assumptions that the speed of light has to be the same. The speed of light has to be the same for everybody, no matter what their motion to the source of the light, all that kind of stuff. It gets to be a real mess. And of course, on top of that mess is we have to measure all this stuff, and we just like to measure stuff, and it gets all to be a mess. So bad assumptions all over the place. The Big Bang. Everything starts out, all the mass in the universe is here, and it explodes. Why? We don't know, but there's all these assumptions. Particle physics. The harder you smash things together, we're always going to get them in little pieces. They're all going to come in good pieces, and this is the way it's going to work. How do we know what we're smashing together? How do we know the rules of the way the universe works when we're smashing this stuff together? We're making it up. We don't really know. We make, oh, well, it's energy, and energy is just a calculation. So we have the problem of no physicality. We have bad assumptions. We have mathematics in place of real physicality. But again, going back to my point is, what does the data tell us about all this? Let's take an example. The redshift. What does the data tell us? Well, the redshift says, and all this expanding universe tells us that, well, the universe is only so big. It's only been around so long, 13.7 billion years, or whatever it is, and that the things that we see really far away that are really new in the galaxy, they can't be fully developed. But then what happens? You look at the data, you go out there into a black field of nothing, put Hubble to look at it, and what do you get? You get really mature looking galaxies way further than they should be. Oh boy, you have data points where you're having real troubles now. So you have to think, well, maybe the Big Bang is the problem. Maybe the data is telling us something completely different. And that's one of the things that we need to do. We need to come up with, okay, if this data says that we have a particle and that's a wave, and that we put a detector in the wave-particle duality experiment of the double slit, where we put some light through it, and when we put a detector, detect it, light looks like a particle. Then light, you turn on the detector, light looks like a particle. You turn it off, it looks like a wave. What is it? Oh my gosh, how do we explain it? We can't explain it. Well, all this data. Well, redshift, maybe we can explain it a different way. Oh, instead of plate tectonics where we have this fixed radius, well, what if the Earth has actually been expanding, and that all bodies in the universe are expanding? And maybe the data is going to fit better. That's what Dr. James Maxwell shows ridiculously, in my opinion, that it fits so well. You have to either be very married to the idea emotionally, or maybe your job depends on it, and you have to stay with the status quo. But if you really look at the data, and you look at the data points that this man, Dr. James Maxwell himself, has put out, oh my goodness, it's really hard to ignore that the data is telling us something else. So we've got to come up with a different model. Excuse me. So what does this all mean? It doesn't mean that models, we just make them up. We have studied all this stuff for many years, and we continue to do so. We continue to debate amongst ourselves about current data. Is it good? Some people will say, yes, it is. Some people will say, expansion tectonics really doesn't exist. Other people say, well, it does. Some people say ether exists. Some people say it does not. We are looking at all these things because there are problems with mainstream. And the other problem we have is that the problems right now are not tweaks. They are not tweaks in any sense of the word. These are fundamental problems. Fundamental problems like the Big Bang is wrong. It's an eternal, infinite universe. That's one of the models. The plate tectonics, a lot of it's wrong. Well, why? Because it's been expanding. And actually, the whole world fits together in a smaller globe. And it explains much more of the data than plate tectonics. Maybe the redshift is wrong in the sense that redshift means things are moving away from us. Maybe, since the Big Bang is such a problematic thing in itself, maybe because, the Big Bang, what you have is you have a new model that tells you why you see red, but it's not because of things moving away from you. It's because of the way light is. So you have these things out there, these models that we look at that are no longer tweaks. They are wholesale replace. Big Bang, we replace with an infinite universe. Plate tectonics, we exchange for expansion tectonics. We have the general relativity for gravity, we replace that with gravitons or gravity particles, or replace that with ether. We don't have any physical explanation for light. We replace that with waves in an ether. We replace that with waves of particles in particle models. We replace them. We come up with better models. Now, why are they better? Well, number one, they have to describe everything that's out there now. Woohoo! And what happens? The dissonant scientists like myself and everybody else, the critical thinkers, say, well, guess what? There's all kinds of things that it doesn't explain, like the double slit with a detector. You turn the detector on to try to detect which slit things are going through, the particles or whatever, the photons, and it turns from waves to particles. And we don't even know why. We have no idea. And if you know, you'll win a Nobel Prize. That's the claim of somebody on the internet who shows this. But the particle model, just as one example, my dad has an explanation for it. And he's got a physicality for light, for gravity, for magnetism, for all of this. He even knows how when you turn on the detector, why it's happening and how. Physically. So, yes, we describe what's there. And we describe things that current theory can't describe. Now, why do people think that we just make up stuff and then we throw out? We don't care if it fits the data. Are you nuts? Why are we wasting our time? Why would we waste our time trying to come up with models that not only that have to actually match the data we see, but explain new things? That's why you do it. If we have no physicality for light and gravity and magnetism, well, if your model has real physicality to it, if it's an ether, if it's particles, whatever it is, if it's a lattice, you are giving the world a better model, because no longer are you talking about simply mathematics or abstractions or arbitrary packages with arbitrary attributes. That is why we build the new models, because we see the problems. We have no misconception about science. In fact, one of the things we find out about mainstream science is they're the ones who violate the scientific method. They're the ones who violate the way you do science. Engineers are appalled. They are horrified by looking at some of these physicists and cosmologists, the way they just talk and they write equations, and the equations are wrong. We have people who go through them, are great at math and concepts, like Stephen Crothers goes through all the math for the black holes, and my goodness, is it wrought with mathematical and conceptual problems. It's just a mess. That's what's happening. I remember hearing on NPR Margaret Wortham and her Physics on the Fringe, which is actually a pretty good book, but she goes out there and she's got to stay on that side of mainstream. And the person really asked, somebody in NPR, I think it was, maybe, he goes, wow, Margaret, is it possible that one of these people in the organization, our CMPS at the time, MPA, would actually come up with something that's going to be accepted, that the next model could come from them? Of course not, she said. That in itself is a dumb question, a dumb statement. It's absolutely there's no logic to that. In philosophy, in debate, to say it will never happen is stupid. It's dumb. Because how many times in history, change always comes from the outside. Why? Because once everybody knows their model and they get their power and they get money, they can build giant colliders, they can give themselves $2 million prizes and hang it on their necks and say, I am a Nobel laureate for something that we made up. We made big detectors. We pretended to find it. And they can explain all the data to you, but they never give you the raw data, you know, and that's kind of strange. But then they give themselves, now, the same year as they find it, they give themselves those rewards. I mean, it's almost like, oh my gosh, we're in a paradigm shift. We better do this now before we die. Of course, it's going to look pretty bad when we're looking back at all the people who got, for instance, awards for neutrinos, and they turn out to be not existent. So for all of those people who wonder about, hey, these new models, are they any good? Do you have proof for them? There's a long process to get to these models. And I'm talking about the better ones, yes. And yes, there are people, like I said, who have their models that they come up with, and they ignore everything else. That's a privilege. They don't ignore the idea that they have to describe things, and they certainly don't ignore the idea that they describe things that our current models can't. So even those guys are doing better. So when you think to yourself, when you see a new model, that, oh, they don't follow the scientific process, scientific method. Oh, they don't care about, you know, the real data. Hey, how about this data? Boy, are you wrong. They're going to come up to you and say, look at this. Look at this double slit thing, right? The one you can't explain. Yeah, here it is. I can. And I have a physical model for everything that I can explain it to the average person they can understand, because it doesn't need math, because physicality of moving mass should be able to explain it. Just like you can explain billiard balls on a table, you can explain the whole universe in some of our models the same way. So I hope this is giving you some ideas or some insight as to when we talk about our new models, ether models, particle models, lattice models, accidental distance models, all of those. New force equations like Dr. Lucas. All of these people. This is not a fly-by-night, put it together, isolate yourself and forget about science. These are real, true progressions of true critical thinkers that come to these models by way of looking at the world and the models we have now, going through these processes of the misconceptions of ourselves, what is wrong fundamentally, no physicality, no bad assumptions, what does it tell us about the world, and we come up with models to describe what's known and things that we currently can't describe. But one of the biggest things I will have to say in closing that the models do that is so needed, and I think this is where I think the silent majority of everyone who on this planet who likes physics and science and cosmology and all that, is we need physicality. We're tired of a bunch of equations that mean nothing, with aperture roots that mean nothing, things that don't make sense, and we still don't even know what light is. We don't know what gravity is. We don't know what. That's where the biggest advancement happens in our models. So I hope you enjoyed this talk about the new models. And I appreciate that person, no matter what their motivation was, on asking me. Proof for your models. Because remember what I said, don't take my word for it. All these models are out there. We're talking about, Dad's talking about it. We've got the Infinity Guru, Dr. Glenn Borkert. He's going to have his channel coming on pretty soon. We've got Jeff Yee talking about his ether model, which is a really great model. If you like even the current particles, he even resolves a lot of things much simpler, much better, much more elegant, describes more with less equations, with less variables. Those are the kinds of models that are out there. Don't take my word for it. Read them. Subscribe to these channels. You want to know about time and special relativity? Subscribe to Nick of Time. All these channels that we're coming out with, we're here. Decide for yourself. Why are we doing it? Why am I doing it? Because this is where science is going. You want to hang out with the people who are going to be the movers and shakers. You ain't going to find them in the towers, the ivory towers of the universities around the world, who just simply perpetuate the same thing, knowing deep down inside that this is going to fall. Well, it's not only fallen, it's not only been examined, the dead corpse, and picked through and analyzed, but there are new bodies and new ideas and new theories out there. And remember, stay critical, stay thinking. I am Dave D. Hilster. I am your science therapist. Ciao for now.